Welcome to the final video in my Python tutorial series. Today we're making our calculator from the previous lesson into a class with methods that we can call to make our calculator more object-oriented, which is the basis of Python. We're not going to go into object orientation, as I assume you've done your own research. What we will be doing is copy and pasting a lot of content from the previous lesson. I want this lesson to be focused on classes and methods and how they work rather than the functionality we went over last lesson. If you want to learn the concepts of what we are copy and pasting, the link to part 2 of this series is below in the description. If you have already watched the video, grab a cup of coffee, open your IDE, and let's begin. So first of all, we will be creating two Python files, one called calculator.py and main.py. Now main is where all the action is going to happen. Calculator.py is our class. We'll start off by declaring class calculator. Now this could be named whatever you want. You can say class giraffe or class computer. It really doesn't matter. This is just a naming preference, and by convention the first letter is always capitalized. That's all there is to creating a class. A class is an object in programming, exemplified by these headphones. Any object has attributes and things it can do. An attribute of these headphones are that they're wearable, and a function they have is to play music. You can press play, you can skip to the next song, you can stop, and you can power them off. So the best way to think of a class in programming is think of it as an object. We have created a calculator, and now we have to give it functions. First, let's give it attributes. The way to create a function in Python is to type def, D-E-F, and then declare the name of your function. The first function we will be making is a special function called init, for initialize, with 2 underscores preceding and following init. And inside of parentheses, we put arguments. We only have one argument in this case, and it is self. Self is a reference to the calculator class itself, hence the name self. And if we want any further arguments passed in, we would separate them by commas. For now, we're only going to use self and set the constants from our previous video. I've copy pasted them from the GitHub, and all we have to do here is put self dot in front of them so we can use it throughout the code. And now we will be setting up the function to get the user's input. Again, I will be copy pasting the meat of this function from the GitHub. Def get user input string. We will only pass self into this function because it is required, and the rest I have pasted from GitHub. We went over these concepts in the first video of this tutorial series, linked in the description as well. The only difference here is that we are returning something. Return is something we have not gone over before. Return ends a function and sends back a value. And if that doesn't make sense now, it will when we demonstrate how to use this method in main.py. And now we will be setting another function to get the 2 sides of the equation as we did in our previous video. And our arguments are going to be self because it's required and user input string. And I will be copy pasting from the GitHub this code as well because it is a repeat of what we did in the second video. Now note the difference here is that we have self dot index of operator, self dot whatever variable we're using. The reason we use self is again so we can reuse these variables in other methods. And now I'm going to copy paste all of the other functions from the GitHub and go over each one. So add numbers takes 2 arguments, self and numbers. We set self sum to 0. The for loop gets a number from our list of numbers that's passed in and adds it to the sum and returns the sum. Now I don't know if you can tell, but this is going to allow us to add together more than 2 numbers, something that our previous calculators were not able to do. Same thing in subtract, we have a difference. This time, we get the index because we have to set the first number in the array passed in to difference. Otherwise, we would be subtracting from 0 the entire time. And else, so whenever it's not equal to 0, we subtract from the total number, allowing us to subtract multiple numbers. Multiply numbers is very similar to add numbers. It just multiplies the same numbers, except product starts as 1, because if it were set to 0, anything multiplied by 0 is 0, and would thus return 0. We return self-product. And quotient acts just like subtract, except with division. So now let's go into how to instantiate a class. Now I know that's a big word. It just means create an object. We can set a variable to our object. Calc is what we will call it, and we say equals calculator. Now we have a warning here that calculator is not defined, and that's because we have to import our calculator because it is a separate file. Because we only need the class and not the entire calculator file, we will say from calculator, this is calculator.py, import calculator, the name of our class, and our warning goes away, and we can add parentheses here to construct our calculator object. Nothing needs to be passed into the constructor, which is our init method. And now we can use calc. Let's say user input equals calc get user input string, two parentheses, to call our method, and nothing needs to be passed in yet. This will set user input to whatever is returned here. We can demonstrate this by user input and now run it. We enter an equation and the equation is spit back out. This is the power of object-oriented programming. We have an entire code block reduced to one line in our primary code. This creates reusability in our code, which is an incredible time saver. Not to mention, much like variables, you only need to change the code in one place. So now we can take this user input and create a number array, calc, get two sides of equation, and pass in our user input. As you can see on get two sides of equation, we have self and user input string. You never have to pass in self. Self passes itself in. But if you add one beyond here, then you have to pass something in. And in this case, we're passing in the user input. And now that we have a number array, we can print calc add numbers with number array passed in. And we can run this and add as many numbers together as we like. 5 plus 7 plus 8 plus 10. And we get 30, which you can verify for yourself that that is correct. And we could test all the others as well. Subtract, boom. Enter an equation here, 50 minus 40 minus 2. We get 8, which is correct. And all of these function the same way. So that is the crash course final part of my Python series on object-oriented programming. If you found this helpful, be sure to like and subscribe, and I will see you in my next video series. Until then, keep on coding.